Okay. Sorry, Jane.
That's okay. 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 So of course, the notion of iterativity comes from rule-based phonology, where it originally referred to a mode of rule application or a particular algorithm by which a rule was applied to a string. So for Johnson, iterative rules are those that can reapply to their output string repeatedly until no targets remain. And I think of this more as sort of exhaustive application where the rule can just keep going. You keep feeding the output back into the rule until there are no targets left. But there's no specification of the order in which those targets are changed. It's just kind of a free-for-all. On any application, any one target can be changed, and then you just keep going until there are none left. And so I think that's not really typically what we think of as iterative rule application. More likely, we're thinking of Johnson's linear rules or the directional rules of Howard, which are quite similar. Which again reply repeatedly to the output string, but they necessarily apply in a direction. So either left to right or right to left. So you must start at one end of the string, and every time you have an application of the rule, you must advance in the string, and then the iteration stops when you reach the other end. Okay, so if we take an example of basic nasal assimilation, so minus consonantal things become plus nasal after plus nasal things, and we could tag this rule as applying left to right. And so then for an input like a nasal consonant followed by 3 vowels, first application, of course, nasalizes the first vowel. And then from there, each application creates another trigger that can apply to an additional target all the way through the end. Okay, and then another approach, we could have instead an iterativity parameter where the rule is instead tagged as either plus or minus iterative. Plus iterative does exactly the same thing we just saw. Minus iterative doesn't, so it cannot reapply to the output. And so the first vowel nasalizes, but then there is no reapplication, it stops there. Okay, all of these approaches to iteration were in opposition to simultaneous application, which was Chomsky and Halley's original proposal for how a rule applies to a string. I think we're all pretty familiar with this. The idea mainly being there is no reapplication. The output cannot feed back into the rule. Targets are identified in the input form and then changed all at once. So the only triggers and targets identified are those that are applied, are those that exist underlyingly. There is no derived trigger. All right, more recently, this has also been called global application. Okay, so if you're using something like simultaneous application, then the question is, how do you get a map or a mapping that includes what looks like iterative application? And the solution proposed by Chomsky and Halley was the parenthesis star notation. So the rule would be instead represented like this, where we have in parentheses a minus consonantal segment with a star, and this is the Kleene star, so it represents an infinite expansion of rules with 0 or more incidences of what's in parentheses. And so it's still simultaneous application, except now anything's identified as a target provided it meets the structural description of at least one of the rules in that infinite expansion. So in our same example, all 3 vowels are identified as targets. They each satisfy one of the rules in the infinite expansion. They each satisfy a different one, but we can still say they get changed all at once. So there still doesn't have to be any reapplication or having the rule apply to its output. Right. This was not favored though. There's a couple of issues that were identified with parenthesis star. The first is we have a disruption now of the adjacency relation between the trigger and the target. So we tend to think that the reason the vowel is becoming nasalized is because it is next to a nasal thing. But according to this description of it, there can be things intervening. There can be in theory, infinite number of things intervening between that trigger and the target. So we no longer have that adjacency relationship. And secondly, more importantly, we have redundancy. So the thing that is in parentheses just so happens to be exactly the specification of the target of the rule, but there's nothing that really accounts for that. You can put anything in parentheses. When in practice we do so, we just so happen to put the target in the parentheses. So there seems to be a missing generalization there. Okay, so it was a pretty, I guess, active debate about the right way to apply rules, and iteration seemed to be favored. And so what happened to that debate? OT happened in one sense. And so in one sense, the question of how to apply rules went away when you don't have rules at all. But of course, in another sense, the question just sort of took on a different form. So first, we can note that in optimality theory, iteration is optimal, right? So if we kind of translate that rule into a constraint ranking, we might have a markedness constraint against a plus nasal thing, followed by a minus nasal thing. And so the winning candidate is what looks like the iteration candidate, we can think of it, where the nasalization has perpetuated through the whole string. Anything less, including what we can think of as, maybe the simultaneous candidate here, doesn't resolve the markedness violation. It only perpetuates it further down the string, right? So optimization would sort of insist that we want iteration. So this was taken sort of a bit further to say that, OT insists on iteration, and that is a good thing. That is on the right track, meaning phonology itself is inherently iterative, right? And so Kaplan put forth a hypothesis called the Emergent Non-Iterativity hypothesis that says no formal entity in phonological grammars may require non-iterativity. In other words, we don't need any mechanism to prevent the inherently iterative nature of the grammar, in this case, optimization. So any case of what looks like non-iteration doesn't need something like an iterativity parameter being shut off, which is not an option in OT anyway. It's going to be explained in some other way. And so this amounts to a prediction stated in kind of rule-based terms, which is there is no phenomenon that must be analyzed with a self-feeding rule that is not permitted to apply to its own output, right? So we don't ever need to actually prevent iteration. Right. So here's an example of what emergent non-iterativity looks like. So Longo has a pattern that has been called non-iterative vowel harmony. So we see in the underlying form, we have a plus ATR vowel in the suffix. And in the surface form, the second vowel of the stem has also taken on plus ATR, but not the first. So we don't see plus ATR spreading through the whole string. We see it spreading one over and then stopping. And so this would be something we call non-iterative, but in Kaplan's analysis, it's instead positional licensing, in that the suffix ATR feature needs to be linked to a prominent position, such as the root. So once it spreads to the root, that goal has been achieved, and so additional spreading isn't necessary. So in other words, this is not non-iterative vowel harmony because it's not even vowel harmony. Right, it's something else. So we don't need something to prevent the otherwise iterative nature of something like an agree constraint, because that's not even the constraint that's at work here. And the argument then is all such cases would be amenable to something like that. Okay. So this is basically where my interest in this project came about. This idea that we're using a term non-iterative, and at this point we're essentially using it in a descriptive way. We describe a pattern and we tag it as non-iterative, but we're not even talking about rules anymore in a lot of cases. So it's sort of a question of, well, what does it mean then to be non-iterative if it's not related to rule application? And so it seems when we tag something as non-iterative descriptively, what we're saying is it should iterate, but it doesn't. Okay. And then the question is, why should it iterate? And the answer might be either that because it's classified as a type of phenomenon that we believe is inherently iterative, such as vowel harmony. Or if we were using rules, which we're not, we would maybe use a self-feeding rule. Right. So there's the idea was to kind of try and pin down more precisely than this what we mean when we consider something to be non-iterative. And so the way I'm going about doing that is to sort of translate it all into formal language theory. So in a formal language theory analysis of such a pattern, we're not talking about rules or constraints at all, but instead we're talking about their extensions. And we're identifying computational properties of those extensions. So an extension is a function or a map. It's an infinite set, potentially infinite set of string pairs, where the first string is the input string, the second string is the output string, and that output string reflects whatever changes are dictated by the process in question. So with these two extensions, based on the third string pair, I might call the first one a non-iterative extension, looking at that output string where only the first vowel is nasalized. And I might call the second one an iterative extension for the same reason, based on that third string pair. But again, these are just descriptive terms, right? There's a lot of assumptions going into that labeling. That doesn't really tell us what's formally different about these two extensions. So we want more of a formal understanding of how they differ. Okay. So within computational phonology, it's been known for a while that if you want to implement something like simultaneous rule application, that's done by matching the rule's structural description on the input string. And if you want to implement something like iterative application, you instead match the structural description of the rule on the output string. Right? So for example, Mons Holden's finite state compiler for phonological rules allows for three operators that differ in exactly that way. So if you enter the rule like this with the two vertical bars, you're going to get an FST that represents a function in which that structural description is matched only on the input string. And then for the other two, these would be what we think of as iterative, where you're matching context both on input and output, depending on the direction, right? So this will look like, again, iterative application, either starting left to right or right to left. Okay. So in my work, I took this slightly further and proposed two function classes as implementations of these two application modes. These function classes are called input strictly local, or I'll say ISL from here on out, and then output strictly local, or OSL. So I'm going to introduce these function classes using their finite state characterizations. There are other characterizations, but I think the finite state models are the clearest in terms of how the two differ in the way they go about the computation. So if we want to model a rule like this, A goes to B after B. For anyone unfamiliar with FSTs, they represent functions by reading in an input string one symbol at a time and proceeding through the states following the labeled transitions And as they read in the input string, they generate an output string. So for this one, the ISL FST, if I have a string like BAAA, I start here, which is a designated start state. I read the first B in and I produce B in the output, and I proceed to state B. I read the A, output B, proceed to state A. And from here, I read the second two A's and just stay put and output them as A. And so I get the output string BVAA, which we can see looks like what we would get from the simultaneous application of that rule. What makes this FST input strictly local is if you look at each transition, you can verify that it leads to a state that matches the input side, not the output side, right? So in all cases, the destination of that transition records what was just read in the input. And on the right side, we have an output strictly local FST, which is largely identical. This time again, read the first B, output B, go to state B, read the A, output B. This time I stay in state B. So when I read the second two A's, they also become B and so forth, right? And so this time the output string is 4 B's, which we can see looks like what we think of as an iterative application of the rule. What makes this FST OSL is instead every transition goes to the state that matches the output side of the transition, right? So for the most part, since most of the transitions are the identity map, you can't tell the difference. You only see the difference in that one crucial A to B transition, which goes to state A for the ISL model and stays in state B for the OSL model. Okay. So these two function classes are incomparable, but they are not disjoint. They have a non-empty intersection. So for some class of maps, you'll get the exact same map, whether you model it as ISL or OSL. And the connection I just drew between ISL and OSL and the rule application modes might lead us to suspect that what's in the fringes, or the sort of crescent moon regions here, are iterative versus non-iterative, okay? But that is not true. So it is true that if you have something that looks like iteration, you are necessarily OSL, meaning you're out here in the non-intersection region of OSL. But it is not the case that if you have a non-iterative map, you are necessarily ISL, okay? And so that means some subset of the things that have been labeled descriptively as non-iterative are in fact in this intersection, which is sort of where that kind of lack of consistency or precision in the term, I think, lies. So the goal here is to identify conditions under which we can draw this line. And ultimately, I'm proposing we reserve this term non-iterative for this strictly ISL region. And so this is going to give us an understanding of how to sort of interpret emergent non-iterativity, right? ISL being that mechanism that we need to enforce non-iterativity. Okay, so to demonstrate how you can get non-iterativity with OSL, right? So going back to the same example, where again, descriptively, the first mapping we might call iterative, the second we might call non-iterative. The first one, again, is in fact strictly OSL, but the second one is actually in that intersection, right? You do not need ISL to prevent iteration in this case, right? So to prove that, here's again two FSTs, though this time they are both OSL. And again, you can verify that by looking at every single transition, and it's going to lead to the state that matches the output side. So for the iterative version, not much surprising here. We see the nasal consonant, we see the vowel, nasalize it, we go to the nasalized vowel state, and from there we loop. So any additional vowels we get will also be nasalized. In the non-iterative version, everything up to the first nasalized vowel is the same. From the nasalized vowel stage, when we read another vowel, we don't nasalize it, and so we go back to the oral vowel state, which means we would need to see another nasal consonant in order to do an additional nasalization. Okay, so again, all OSL cares about is that you follow the output, right? It doesn't care what the output is. What the output is an empirical question, right? So put another way, nasalized vowels are either a trigger or they're not. That's not a formal distinction, it's an empirical distinction, right? Okay. All right, so again, that would be an example that is in this intersection, right? OSL does not enforce iteration. Okay, so then the first attempt at defining what we really mean by non-iterativity, or proposal for what we could mean by it, is that a non-iterative map is a self-feeding ISL function, right? This is the first version because it still has a term in there that's tied to rule application. The idea is to move away from that and express it in terms only of extensions, right? So self-feeding is a rule-based term. So ultimately, I want to replace that with something independent of rule application and instead talk about the extension itself. All right, so to do that, I'm first going to define two sets. The set triggers is the set of segments that trigger a process. And then we'll let the set called outputs be the set of segments that result from the process. So not the targets, but what happens to the targets after the rule has applied. And then I'll define two terms. We'll say a phonological map is output non-distinct if the intersection of these two sets, outputs and triggers, is non-empty. And the map is output distinct if the intersection of those two sets is empty. Okay, so just applying these definitions then, our iterative mapping, the set of triggers includes nasal consonants and nasalized vowels. The set of outputs includes nasalized vowels, so these have a non-empty intersection, and so they're output non-distinct, or the map is output non-distinct. Whereas in the non-iterative example, only nasal consonants are triggers, so the intersection with the set of outputs is now empty, and so we'd say this is an output distinct map. Okay. So then comparing, like sort of lining up that property against using an OSL function, we'll see you will get iteration with an output non-distinct map. With an output distinct map, you can use an OSL function, but you're not going to get iteration. So at this point, I have non-iterative in quotes because I'm now both using the term in its descriptive sense and trying to define it formally. And so I hope that's not too circular, trying to avoid that, but I haven't found a way. With ISL, it doesn't matter. Actually, ISL simply isn't capable of iteration. So regardless of the output distinctness of the map, you're going to get non-iteration with ISL. So then again, this tying it back to the way these classes interact, we now have a way to sort of diagnose where you are in these regions. Are you on the fringes and necessarily one of the two? Or are you in the intersection, in which case it doesn't matter, right? And so again, the proposal is to reserve the term non-iterative for this region here. Okay, so that means the definition becomes a non-iterative map is an output non-distinct ISL function. All right, so I'm going to apply that to 3 examples of vowel harmony. And first, just to make a note, vowel harmony is traditionally thought of as a long distance process. That's because in a rule-based analysis, we might use this C sub 0 variable, which stands for 0 up to infinity consonants intervening between the two vowels. If you take that seriously and model the function that that represents, then nothing I just said matters, because it's not going to be an ISL or OSL function anyway, because that strictly local designation means you have a fixed window of memory that you, and the C sub 0 would just flush that memory. You would never be able to hold on to the last vowel anyway. But in the interest of putting that distinction aside between local and long distance, I'm just going to ignore that and not take C sub 0 seriously. And I'm just going to be modeling maps of vowels to maps, I'm sorry, strings of vowels to mapped to strings of vowels. And you can think of this in a couple of ways. Either the map is applying to some vowel tier, or we can acknowledge that the number of intervening consonants is not in fact unbounded. It will be fixed by the syllable structure in the language anyway. And so we could just set the memory to cover however consonants would be there. But for presentation purposes, I'm just going to pretend they're not there. Okay, so if any of that upsets you, feel free to ask me about it in the question period. The goal is just to think more about input versus output and iteration and put aside the representational choice. Okay, so Bengali ATR harmony has been presented as non-iterative. And so the description is that the mid vowels become plus ATR when they precede a high vowel. So here we have the mid vowel plus ATR compared to this form. So we see before the high vowel, we see that change taking place. And in a longer form, we see that it's only the vowel closest to the high vowel that takes on plus ATR. This one remains minus ATR. And so the map could look like this, which again, descriptively looks like non-iteration. So if we apply our definitions, it's crucial here that only high vowels trigger. Okay? So it's not just about being plus ATR, it's about being plus ATR and plus high. So that's our set of triggers. The targets are mid vowels, and so the outputs are also only mid vowels. And so the map is output distinct. And so it's in the intersection. Right? And so not truly non-iterative. Right? Second example from Karmeen Tatar, initial round vowels trigger labial harmony on the next high vowel. The underlying forms here are based on dialect comparison. This is the central dialect. In other dialects, they vary in having either iterative harmony instead or no harmony. And so in this dialect, we have an initial round vowel, and we see in the output form, the next vowel over is also plus round, but not the one after. Okay, so again, looks non-iterative. Right, and so this time at first it seems the set of triggers is round vowels. The set of outputs is also round vowels, so it looks output non-distinct, but then we can factor in the aspect of the description that it's only initial vowels that trigger, right? So again, it's not sufficient to be plus round, you have to be plus round and plus initial. So I'm using here a superscript word boundary as a way of distinguishing the two sets or marking that distinction. So just as with Bengali, the map is output distinct, and again, in the intersection, all right? So if that bothers you, if you think I'm cheating, I'll just say two things. One is that I'm not proposing a diacritic be introduced. When you define these sets, this is just an analytical tool. It's not a statement about anything in the grammar, okay? And all it's saying is we have some way of knowing which vowel is the first vowel. And I argue that that's no different from what's required by a rule like this one, or in the OT analysis of McCollum and NAPhCxi, they use a type of agree constraint that also has the word boundary embedded in it, right? So it's the same, whatever knowledge is necessary to enact these analyses is what I'm saying is present in this identification of what's a target. All right, then the third example, also labial harmony, this time from Kazakh. And so a plus round vowel triggers harmony on the following vowel. First two examples looks very much like the previous case. So initial round vowel triggers rounding on the next vowel, but not the third. And comparing these two examples, we see that it doesn't matter whether the second vowel is in the same lexical item or in a following affix. It's the next vowel over that gets changed and no further. But in the third example, we see this time it's the second vowel that's plus round and it triggers harmony on the third vowel. Okay? So this time there is nothing that can distinguish the set of triggers from the set of outputs, right? There's no featural designation, there's no positional designation, right? So this time the map is output non-distinct. And so since it is doesn't iterate, this would be a case where we actually do need ISL as a mechanism for preventing iteration, right? So this one is in that fringe area. Okay, so you might have thought by now, what about dissimulation? And it's true, if you think it through, these definitions as stated do not work for dissimulation. So if we think of a basic dissimulation, generic dissimulation, L becomes R after L. You can think of this as liquid dissimulation or tone, Sandi, pick your favorite. The trigger is L and the output is R. And so by definition, the map is output distinct. And the prediction at this point would be that both ISL and OSL will produce a non-iterative map. So first we can ask, what does it mean to be non-iterative with dissimulation? What does that even mean? And so we might think in a case like this, it means you dissimulate one time and then no further. But if we actually think back to the connection between non-iterativity and simultaneous application, the output would actually look like this, right? So all three of the non-initial L's are targets according to the underlying form. And so simultaneous application would change all three, okay? Which seems a little odd because it's dissimulation. And so we're replacing one sequence of identical things with a different sequence of identical things. And yet this is attested. So Tone Sandi includes a rule that does exactly that. So a rising tone becomes high before another rising. And so when you have a sequence of 3 rising tones, you do get two high tones followed by the rising. Right? And so the good news is that's exactly what ISL does. It will, once it sees an L, has to follow the input. So it's going to keep seeing L's, it's going to keep turning them into R's. And so you're going to get that kind of multiple changes, even in a non-iterative context. The bad news is OSL was predicted to do the same thing, and it does not, right? So in OSL, once you see the first L, you change the second one to R, but now you have to follow the output. So you move to state R, and then now you're going to just flip-flop between these two states, and you're going to get this alternating pattern. So on the one hand, that's good because this is also attested. We do see this in dissimulation maps. The only problem is it's not the prediction of the definitions as I currently stated them. So that is future work to address that gap. It's not surprising. Those definitions make sense in the context of a self-feeding map or rule. And dissimulation is not self-feeding, it's self-bleeding, right? Every application of dissimulation removes a future application, does not create one. So whether a single set of definitions can encompass both scenarios, I don't know. It would be nice, but I suspect it might be problematic. But moving forward, I'm just still deciding on ways to address that. Okay, before I wrap up, just one last point, which is there is another set of rules that are necessarily ISL for reasons that don't have anything to do with iteration. And that's rules with a two-sided context. The reason they're necessarily ISL is technical, and I won't explain it right now. I can explain it in the question period if anyone wants to know. But I have here a quote from Leitner, taken from the literature on that question about rule application. And in this, he puts, it's an empirical observation that rules with a two-sided context are noteworthy in that the direction of iteration is irrelevant. You can go either from left to right or right to left and get the same thing. And the reason that's striking to me is because that is also exactly true of ISL, right? With OSL, the direction matters. You're going to get a different map, whether you read from one end or the other. With ISL, it doesn't matter. You're going to get the same map. And so this empirical observation is directly reflected in the formal properties of ISL, which is what we need anyway for rules with two-sided context. So I would argue here that it's not that the direction of iteration doesn't matter, it's that there is no iteration, and rules of this form are input oriented. And so I wanted to sort of look into this empirical observation more, because the counterexample would be a rule with a two-sided context that does iterate, right? And so I went in search of such a rule, and I went to PBase, which is a database of phonological patterns, which has just over 4,500 rules in it. So this is how I spent my time in quarantine. I don't know about the rest of you, but I sorted through hundreds of phonological rules. Of those 4,500, just over 1,200 have a two-sided context. Of those, 243 of them are epenthesis, and that's important because epenthesis rules are the one exception to what I just said. OSL can handle a two-sided context if it's epenthesis, and again, I won't go into why, but feel free to ask later. Of what's left, 947 of them can't iterate no matter what, right? They're just not self-feeding. For example, a lot of them involve the word boundary, right? It's not going to create additional targets and triggers. And then among what's left, they could potentially iterate, but to see it, you're going to need a very specific data point that you're probably not going to find. So for example, Estonian has a gliding process in which we get a glide intervocalically. So to know if it iterates or not, you would need a sequence of 4 vowels, right, to decide, and you're not going to find that, most likely. I came very close in one example. I got very excited for a moment. In Masai, we have a vowel deletion. E is deleted after E and before a bunch of things, including E itself. So if you could get 4 E's in a row, you would be able to see it. And I didn't, but I got 3 in a row, which was as close as I could get. So that was almost an exciting day. So again, it's completely ambiguous without a data point of that form, whether it iterates or not, right? So this is not surprising. I didn't expect to find the data to solve these questions, but what is noteworthy is that finding such a rule is certainly not easy. They're certainly not all over the place, right? It doesn't seem like that's something that's, if they exist, they are very rare. Right, so to finish then, there is computational support for this idea of emergent non-iterativity, meaning some things that we would call non-iterative don't require a mechanism for non-iteration, in which, in my terms, that mechanism is ISL, or input-based computation. So this has led to a proposed definition of non-iterativity as a output non-distinct necessarily ISL function, which do exist, right? So the hypothesis doesn't hold, but there are more things in that intersection than we might first believe. And then more broadly, I think knowing these conditions under which your map is ISL, OSL, or both is important. Very often things are reported to be ISL without verifying whether they're also OSL. And I think the distinction is important because it's not the case that phenomena are evenly distributed across these classes. So knowing exactly what role each type of locality is playing in the grammar, I think is important moving forward for the nature of that grammar and how these things interact. Okay, thank you.
Thank you, Jane. We have full 15 minutes for questions, just on this talk, and then we'll have some general discussion time.
Hi, Eric.
Hey, sorry, I tried to raise both hands.
Oh, sorry, I didn't see it. Go ahead.
That's okay. Hey, Jane, thanks very much for this talk. This was very interesting. I had a couple of observations along the way that I don't know if these will help you because it seems like you had already thought about these pretty deeply, but I just want to say them anyway. So one was, it seemed like you were going to be saying that if the output of the target is the same type of object as the trigger, then you expect that to be iterative. And there's, like you said, there's an out. You can basically say that that's ISL, and then you don't, it doesn't have to be iterative. So, but I'm wondering if you've thought any more about that prediction about OSL maps.
So I think kind of the prediction that we expect it to be OSL and sometimes it's not, that kind of.
No, so sorry, maybe I didn't say this clearly enough, but you know, if your output, if your trigger set and your output set are the same, and there's no sort of like trick to call it, you know, the initial vowel or anything like that that can get you to treat them as different objects, then as long as you don't have an ISL analysis available, if you only have OSL available to you, then you predict that that has to be iterative, that it can't be non-iterative. Is that right?
That's right, yeah.
Yeah, and I guess I'm wondering if that's of interest, that it makes that kind of prediction, or is it the fact that, you know, you have an ISL analysis available to you that makes the prediction just basically nonsensical because it doesn't match up with anything?
Yeah, so I mean, I think at one point, the idea was if the emergent non-iterativity hypothesis is right, then that would mean all we need is OSL. That would be one way of thinking about it, right? And initially I thought, well, that'd be great, actually, because if you only have one type of function, that simplifies a lot of other stuff, such as learning and how things get combined into the grammar, right? So it seemed, and it seemed very promising, actually, for a while. A lot of the cases I was looking at were all in the intersection. So I thought, okay, great, maybe we're right. And phonology is iterative in that sense, or it's output oriented in that sense. But then finding cases like Kazakh, it just seems, well, it's just not true then. It seems, at least in these terms, we can't get away with only OSL. Like we do need ISL. And this is just a way of understanding more clearly when and why, I guess. Does that answer?
Yeah, I think so. You know, maybe I was fishing for something that's not actually there. You know, like one wonders if the Kazakh example, if you could come up with some similar type of trick. It's not position of the vowel, but there's something else about the acoustics of the vowels that haven't been recorded, or, you know, like it basically becomes an exercise in trying to figure out what could be the differences between these triggers and outputs.
Right, and so that in that Kazakh example, that third example, the data point that showed that really settled it is actually a loan word. So you could then you could go there and kind of, you know, question it. And I think I'm not really committing myself to an analysis of Kazakh. I'm just saying this is what we're looking for. And so, and I think when you start doing those things and saying, all right, here's a way to get them separate, you know, you also need to be checked and sort of how far are we going to go? Like how important is it to us to stay with OSL? What are we willing to allow in order to draw those distinctions? And I think that's those are interesting conversations, and I'm not making solid claims about it. I'm just providing, you know, a framework to do those things.
Right.
Yeah.
Okay.
Right. And then the other thing I just wanted to mention real quick, sorry, is the two-sided environments. I think you might want to look at those a little bit more closely too, because there's many cases of two-sided environments in which people have argued that those actually represent other things, right? So the doubly sided open syllable environment has to do with syllables, you know, not with strings of V's and C's. And also the a two-sided vowel environment sometimes has to do with non-initial onsets or something like that, right? So one might want to look at those cases a little bit more carefully in that regard.
Yeah, thank you. It was really striking how a great many of the two-sided contexts are intervocalic. Like it does seem, and so that it does, I had that thought that there's something going on there, that there's a reason that they might be separate in that way. And the only other possible case is alternate vowel deletion. But then when I've looked into those two, and there's always something else going on, like you're saying, right? The only reason it's a two-sided context is because you can't delete the final vowel, right? So there's always another factor it's not strictly a trigger that's creating that context. There's something else going on that's forcing us to write a rule with a two-sided context. So I think that's what's noteworthy, is that there is something always going on there. And then they are noteworthy in that regard, and then they're noteworthy computationally. So yeah, thank you.
Hey, Dr. Rowski.
Hi, Jane.
Hi,
What a great talk. When I was looking at your slide that had the iterative and the non-iterative OSL example, what struck me was that the loop, maybe you could go back to it, it might help me clarify my question a bit. It was the nasalization example where you had the iterative and non-iterative OSL.
Yeah.
So in the iterative case, there's basically just the structure of the FSTs was different, right? So you have, in the one case, you just have a loop on the nasalized vowel state. But the non-iterative case, it seems like there's like a weird notion of look ahead, where you're sort of passing the string through another conditioning environment in order to do the same thing, right? So you sort of, that V to V transition now sort of passes through the FST a bit more. So what I'm wondering is there some relationship between this type of non-iterativity and the subsequential functions, which their defining property is bounded look ahead? So it seems like the non-iterative case requires there to be some sort of bounded, it's not bounded look ahead, but it's just a weird, I need to see something else now, namely this nasal, in order to then nasalize something again. Whereas in the iterative case, I don't really need to see that.
Yeah, so I think that's just sort of a phonological interpretation of it. Like formally, it's not doing anything but what it does, which is follow the output, right? And I guess it depends on what you mean by look ahead. So, looking ahead in a way of sort of, typically I think of look ahead as I can delay output until I see what's coming, right? OSL can't do that because doing that requires outputting the empty string temporarily.
Right. Yeah, so that's why I'm wondering,
yeah.
Is there some distinction that we might make within the OSL functions between functions that could do that, right? And then it can't do that, right?
So by definition, if you output the empty string, you can't change state.
Right.
Because the state has to be a record of output. So if you don't output, you can't move, right? And so if you output an empty string in OSL, but you are basically deleting, you have no choice. There's no way to recover that, right? With subsequential, you can. With ISL, you can, right?
Yeah, right.
Actually, the exact reason you can't do a two-sided context. And so there's no formal look ahead in this. It's just we're just sort of, that's our phonological lens saying, oh, you need another nasal to nasalize again. That's
yeah, right. That's why I wanted to sort of ask was whether there was a formal analog to this phonological intuition we had. But okay, thank you.
Anyone else? I'll ask one to Jane about, I don't know if I'll be able to characterize it correctly, but this issue of whether the outputs are identical to, or they're members of the set of triggers. Is that the right way to say it?
Yeah.
So this is something that's been bothering me. Basically, once you use alpha notation or Greek variables, your notion of natural classes gets completely screwed up, right? So what if, so I guess what I'm trying to say is being a trigger could be kind of context dependent, right? If you have the same alpha value as the thing next to you, right? You might, and so it might be, I don't expect you to solve this, but could it potentially make your life more complicated? If being a trigger is context dependent.
Right.
You know, I'm only going to trigger a rounding if I share height with the vowel next to me, something like that.
Right, yeah, I haven't thought of that. At this point, that would just say, you know, everything that could be a trigger, context or not, is in that set so far. It would force that, and then so there you're not really like lining up your triggers and outputs. You're just it's a very simple relationship. Is the intersection empty or not, right? So
So it probably wouldn't matter, you're saying.
yeah, I guess it doesn't matter. Yeah, I guess that's what I'm saying.
Good, good, good. Anybody else?
Well, I'll just follow up on that point just slightly. I mean, so in the case that the things are both located on the sort of preceding segment, like, you know, a parasitic rounding or something, then you're just going to have more states in the diagram. Like, but the thing is not that much more complicated. But you can have a, you know, longer string context for this. Like you could imagine, like, you know, I only do this if there are two segments before me plus the triggering segment. And then, you know, then you've got a larger diagram. And then the question is, where does the loop go? Like, so it could go, like, so when you say it sort of stays in the same spot, you know, like that's easy to figure out when there's only one symbol of context. But if there's a multiple symbol of context, then you're going to have to sort of ask, well, where should this, you know, where should the output loop go on this thing? Like, so should it go back? If it goes back to the same state, then we're saying that it shares the same context. Now, in some cases, like, you know, that you just say, well, I had to have seen two segments before me, that context will obviously be able to be pushed through the form. Because, like, you know, once you've seen two segments, then you've always seen two segments. But like, if it has more to it than that, you could end up anywhere in the diagram, depending on what those, you know, links of states are representing. So, like, I think that that's the more important question is there a sequence that you're looking for that's the trigger where, you know, it can't be reduced to just a single item?
Yeah, right. Yeah, and these diagrams get ugly real fast, which is why I usually don't include examples of that form. But I mean, you're right, it would not be a loop, it would be a cycle. And I think the same kind of predictions would come about, whether it's forcing iteration or not. And then and defining those sets with substrings instead of single segments is also an option. And I suspect that might help with dissimulation, but I'm not sure yet. So I haven't worked it out, but yeah, certainly this stuff is most clear when you're dealing with just a window of two, or a rule of structural description of length two. But in theory, it should extend to larger windows. I will see.
Okay. So are there any other questions specifically for Jane? No? Okay, so what I'm going to do is I'm actually